Hello, I am Ekim.
I am Bahadır Özkür.
Today we will present a final project with Raspberry Pi Pico in İzmir Demokrasi Üniversitesi. I will explain our code. After that, Bahadır will explain our circuit. Now, I want to talk about purpose of application in this project. The purpose of this code is to build a fully functional, smart, safe prototype that controls a physical locking motor using a rotating deal for password entry and uses sensors to prevent accidents. Thanks for listening us. Hello, I am Ekim now. I will explain our code. Now, first of all, I want to start with this part. It imports machine to control hardware pins like GPIO, ADC, and I2C, and time to manage delays. Constants LDR min and LDR max define the acceptable range for ambient light. If the light is outside this range, the system assumes that there is an obstruction or tampering. This part, a threshold to filter out signal noise from the potentiometer. This part, lock timer target, the duration before the safe automatically locks itself. In this part, we start with class I2 LCD to there. This block defines the class of I2 LCD. This is hardware abstraction layer. It translates simple Python commands into the complex binary signal recorded by the LCD screen via the I2C protocol. Init initializes the screen and sets it to 4-bit mode. Clear wipes all text from the display. Put CTR writes a string to text to current cursor position and move to command is moves the cursor to specific coordinate on the screen. Now this part, which start with I2C LCD to there. The code initializes a sensor and actuators. It also scans the I2C bus to automatically find the addresses of LCD screen, preventing connection error. Now, this part, which start with def, def RGB controls the color of the LED. It automatically adjusts for common anode or cathode wiring. This part activates the buzzer for T seconds to provide auditory feedback. This part, the step motor part, rotates the stepper motor. It iterates through a magnetic sequence to move a motor shaft precisely. This part and this part, dev motor open and dev open, dev motor close. Specific commands to move the motor 5, 1, 2 steps forward or backward to unlock the door. This part, dev show, a safe wrapper for the LCD. It clears the screen and writes 2 lines of text. It includes a try except block to prevent the program from crashing if the screen is disconnected. Now this part, dev stable LDR and dev stable pod. This function implements software filtering. They take multiple readings and calculate the averages to ensure the sensor data is stable and accurate. Now this part, which start with dev ışık control up. This acts as a safety interlock. It continuously monitors the environment. If the sensor is blocked or the light is unsafe, it halts the system operation. Main loop is while true, which start with while true. The system initializes print system ready and enters the infinite while true loop. The safe resets is state at the beginning of every circle. This part, which start with while true. In this phase, the user defines the one-time password for the session. The LED turns blue. The code reads the potentiometer and maps it to number between 0 and 1000. The screen updates dynamically as the user turns the knob. If button 14 is pressed, the current value is saved as the code. If button 15 pressed, the value is reset. Now this part which start with there. The safe is now locked and the user must enter the correct code. Process the user rotates the knob to find the code. Verification when button 13 is pressed, LED turns green. If incorrect, access denied is displayed, the buzzer sounds and the user must try again. Now this part which start with there. A counter triggers a beep and LED blink every few seconds to remind the user the safe is open. The system checks the LDR sensor. If value smaller than LDR min, it displays obstacle and resets the timer. The door will not close. If the path is clear, the timer increments. When it reaches approximately 8 seconds, the system entails the time up sequence to close the door. Pressing button 15 force the door to close immediately. Now this part, which start with motor close, is called to physically lock the door, and the system displays locked, resets the LED and restarts the main loop for the next user. Now I want to show our circuit. When I restart this code and start, you see blinking blue color on RGB LED. After that, when I set password for 21, after that I will when I press this button and press again for entry password, you can see stem motor is rotating. After that 8 seconds you see in there step motor rotate again. Thanks for listening me.
Hello, my name is Bahadır Özgür. Now I would like to explain the circuits that we have built. First off, I would like to talk about components used in our world, or circuits. One Raspberry Pi Pico, 2 buttons, 1 LDR sensor, 1 10K resistor, 3 470 ohm resistor, 1 buzzer, 1 common cathode, RGB LED, 1 I2C LCD display, 1 stepper motor driver. Now I would like to explain connection. First we displayed it V bus pin 5 volts, which is the 40 pin of the Raspberry Pi Pico. Then we connect the VD pin stepper motor driver to this 5 volt line. After that we connect the ground pin to driver to ground line. Next we connected GP2, GP3, GP4, GP5 of the Pico the in 1, in 2, in 3 and in 4 pins of stepper motor driver. Then we connected the stepper motor wires to driver. In this way, installation of stepper motor was completed. After that, we connected I2C LCD display. The VCC pin of the LCD was connected 5 volts. The GND pin was to grounds, and SDA and LCL pin were connected to GP0 and GP1 pins of Raspberry Pi Pico. Thus, the installation of the LCD display was completed. Then we connected confirmation button by connecting LED GP14 and other leg to ground line. The reset button was connected GP15 and other leg was also connected ground line. In this way, the button installation was completed. Next, we connected LDR sensor. One leg of LDR was connected 3.3 volts, which is the 36 pin of Pico. Pico and other leg was connected ADC GP27, which is 32 pin. We also created a voltage divider by connecting 10K resistor between this pin and ground line. After that, we connected RGB LED deck. RGB pins connected GP10, GP11, and GP12 respectively. The Canon cathode pin was connected to ground line. Finally, we connected potentiometer. The middle pin was connected GP26 ADC 0, which is the 31 pin. The left pin was connected 3.3 volts and right pin was connected to ground, which with this connection the circuit setup was completed. Now I would like to explain working principle of circuits. When system detect too much light or little light, the buzzer sounds, and this station we cannot enter the password for smart lock system. Under normal light condition, the password is ejected using potentiometer, and when it's confirmed using button, the stepper motor rotates and work like a locking mechanism. After waiting 16 seconds, the lock is opened automatically. Now, The reset button reset the password when it's pressed on the password entry screen or after the password entered. The RGB LED light blue and under normal light condition and lights up red in other connection, which means that system cannot be locked. Thank you for listening.